Dear students, welcome to lecture number 28. Today in this lecture we will be going to solve a design problem, and in this design problem we will be taking problem related to uni-axially loaded rectangular type of RCC column, and this design will be based on SP-16. We will be taking help from SP-16 and following the guidelines which are mentioned in IS 456 as well as SP-16. So let first of all we discuss the problem statement. So here in the problem statement is given that we have to design a short column, and that is having rectangular type of cross section, and the unsupported length is given, that is 4 meter, and this column is subjected to a factor load of 1800 kilonewton and a factor movement of 90 kilonewton meter. Again we have to adopt M25 grade of concrete and Fe 415 grade of steel, and we can assume mild type of exposure conditions. Now in step number 1, as usual, we have to select the grade of concrete and steel, whether it is given in the statement or we have to assume as per a guideline in the IS 456. So here it is given in the statement that column need to be designed as a short column. So that means when the information is given that column need to be designed as a short column. Unsupported length is given, that is 4 meter, and end conditions. So no end conditions are specified, even they are not required, because it is clearly mentioned that it is a short type of column. We have to design taking into consideration the guidelines as well as the formulas which we use in designing a short column. Now it is decided that column will be a short column and loaded axially and as well as uni-axial movement. So that means the column will be subjected to axial load plus uni-axial movement. So that means some movement is also associated with the axial load. And the column is supposed to be exposure to mild type of environment. Now it is decided that grade of concrete is M25 and the grade of steel is Fe 415. And nominal cover for reinforcement, as we take that it is 40 millimeter. So adopting M25 grade of concrete and the steel bar of Fe 415 grade. Now in step number 2, we have to determine what should be the size of the column. As we have discussed that we have to design a rectangular column. So axial load is given, that is factored axial load is given 1800 kilonewton, and based on the loading system we can assume. So here we are assuming 1% of the self weight of column. That means 1% of the axial load we will be taking as a self weight of the column. So self weight of column comes out to be 18 kilonewton, and so total factor load will be 1800 plus 18, that is 18 kilonewton approximately, we can say. Now here we have to assume the area of longitudinal steel. So we have assumed 2% of cross section area of the column as area to be taken as a longitudinal steel. So based on the formulas, that means ASC is equal to 2% of AG, and AG is AC plus ASC, that means area of concrete without steel plus area of reinforcement. So rearranging again, AC can be calculated by subtracting ASC from AG. So ASC minus AAG minus ASC, that is equal to 1 minus 0.02 AG. So that means area of a concrete in the section will be 98% of a cross area of section. So we can use this formula as generally we use it in case of a short type of column. So here we are going to design a short column. So putting all the information which we have collected or calculated so far, So grade of concrete is M25 and the grade of steel is 415. And after doing the calculation, we are able to get that area of gross section required is 118400. Now here we have to design a rectangular type of column. So we can assume some dimensions. So by assuming width is equal to 300 millimeter, so accordingly we can decide depth is equal to 400, so that this section should give area more than gross area which is required. So gross area, if we providing a section 300 by 400, so gross area provided will be 1,20,000 millimeter square, so which is greater than the gross area required for the calculations. So in step number 3, we apply the check for checking whether it is a short column or long column. But since in this statement itself is given that it is a short column, so no need to check it. However, you can check it for your clarity, no issue. But here we are skipping this step, so that means since it has already been classified as a short column. Now in step number 4, we have to check for the apply the check for the minimum eccentricity. So minimum eccentricity is given by this formula that is available in IS 456. So based on this formula and after putting the value, we are getting minimum eccentricity 21.33, which is a greater than 20. So it's okay. And now we have to work out what is the actual eccentricity due to the loading. Since the moment is given as well as actual load is given, so putting all this information, we are getting that is equal to 50 millimeter. So which is here you can say which is greater than 21.33 instead of 23. So we can say it is okay. Now here we are assuming lateral ties of 8 mm dia and the longitudinal steel which we are going to provide. We will be taking 28 mm dia bar into practice. Now in step number 5, we are going to do the calculation for design of longitudinal reinforcement. So you can easily see from this diagram also that when we have decided that this will be the cross section of the column which we are going to design. It is a rectangular type of column, and this is axis of bending. So parallel to axis of bending, we will be going to provide the reinforcement, and later on we will be going to design this reinforcement. So here D dash will be the effective cover to the reinforcement. So lateral ties which we are going to provide, we have decided that they will be of 8 millimeter dia, and the longitudinal steel will be of 28 millimeter diameter bars. We have already assumed, but currently we have not decided any number of bars. So this diagram is only for the representation purpose, so that we can understand what is capital D, what is small b, and what is D dash. Later on, how many number of bars we are going to provide, so we will be modifying this diagram. So this is a diagram only for the illustration purpose. So here capital T, that means longer side is 400 millimeter, width we have taken 300 millimeter, clear cover to the reinforcement we have decided that is 40 millimeter. So accordingly we can work out the value of D dash, because D dash is center of the main reinforcement or longitudinal reinforcement from the outer surface of the section. So here we have not shown that we are providing here lateral ties, so we will be taking into consideration lateral ties also. So 40 millimeter was the clear cover, 8 millimeter is the diameter of the lateral ties which will be surrounding this main reinforcement, and half of the diameter of this bar we have to take into consideration. So after doing the calculation, we came out with D dash is equal to 62 millimeter. Now capital D is 400 millimeter. So we have to work out this value, which is very important for us, D dash by capital D, because based on this value, we will be able to select the chart from the SP-16. So we are getting D dash by D is equal to 0.155. So we have just a rounding off for this particular solution of this problem. So we are rounding off it is to 0.15. Now small PU we have to calculate, which is required to select the chart number. So after putting all the data, we are getting small PU value is equal to 606.606, and the third parameter which is required, small mu, that we are getting after calculation, it is 0.075. Now in continuation to this slide, we are going to let us try to understand that how the chart will be selected and how we have to pick the value from the chart. Now as I discussed in the previous section that we have calculated d dash by d is equal to 0.155, which we can take approximately 0.15 also, and the small PU which is 0.606, small mu is 0.075, and the grade of steel we know that we are taking it is Fe415, and it is a rectangular type of column. So based on this information which we have collected, we can select the chart. So here we will be going to understand how to use charts in SP-16. So based on this data, we will be able to select the chart number 33, because chart number 33 will be relevant to the data which is mentioned here, which we have calculated. And here we have taken that we are rounding off this d dash by capital D 150. So chart will be based on this data. Now we have selected this chart, that is chart number 33 from SP-16, and in this chart I have illustrated in design steps also. That means along vertical direction or along y-axis we are having value small pu, along x-axis we are having values in the range of 0.1, 0.2, like that. That is the value of small mu. So from this chart, based on the data which is we are having, that is PU is equal to 0.606, MU is 0.075. So based on this information, we have to select that where these 2 points are getting intersected. So we are finding that here somewhere here they are intersecting, because this value is related to 0.606, and from here it is 0.075. So based on this value, you have to pick the point here. So we are able to get this particular point, and this point belong to or lies on the curve where P by FCK value, that is that is P by FCK value, smaller p, small p by FCK value is 0.12. So it is lying on this curve. So therefore we can easily calculate what is the percentage of steel required. So we get this value small p, that is percentage of steel, that is equal to 0.12 into FCK. FCK was 25. So we are able to get here that required percentage of steel is 3%. So based on that, we can calculate what is the area of steel required. So area of steel is percentage of steel into gross cross-section area divided by 100. So after doing the calculation, we are getting this figure. That means area of steel required as longitudinal reinforcement is 3600 millimeter square. So let us provide 6 number of bars, 28 dia, H by SD. Since this 3% steel is following the guideline which is mentioned, or you can say limits mentioned in IS 456, that is, it is lesser than 6% as well as greater than 0.8%. So here we have decided that longitudinal reinforcement which we are going to provide will be 6 number of bars or 28 dia high strength steel bars. Now let us check how much spacing is available when we insert or we use 6 number of bars. So area required, as we have discussed, 3600, and we have decided to provide 6 number of bars of 28 dia. So based on this, we are able to provide this much area, 3700, and the required was 3600. So this is okay. Now here we can understand this diagram more clearly. So this is the cross section diagram, and the red color surrounding is a little tie, and that little tie is of 8 dia bar, which we have preliminary, we have assumed, and later on we are going to check it also. So this side is 300 millimeter and the longer side is 400 millimeter. So when we provide 6 number of bars, which we have to provide uniformly on both sides, so 3 number of bars on one side and 3 number of bars we will be providing on the other side. And effective cover which we are getting, that is 62 millimeter. Now distance between these two bar we are getting, that is 276, so it's okay. And along this direction we are getting 88 millimeter center to center spacing. So this 88 millimeter center to center spacing is sufficient, because minimum spacing must be required, so that it should be at least 5 mm above the diameter, or you can say nominal size of the aggregate. So it is quite sufficient. And second is this spacing 276, and the code allow 300 millimeter center to center spacing. So both direction we can say this is the actual or sufficient steel which we can provide along with sufficient spacing between the adjacent bars. So from this we are getting spacing that is equal to how much spacing we have provided, that let us understand. It is 276. 62 we have subtracted in this side, 62 subtracted in this side, so out of 400 we are getting 276, which is lesser than 300 millimeter. Your code is recommending, or code is limiting that maximum spacing should be 300. That means you can't go beyond spacing more than 300 millimeters. So it is sufficient, it's okay. Now the reinforcement area as well as spacing between bars is sufficient, and we can say it complies the guidelines of IS 456. So here we have decided already, and now it is checked also, that longitudinal steel is provided as 6 number of 28 mm dia are uniformly distributed along two parallel sides of the rectangular column. Now let us check the guideline regarding transverse reinforcement, which we are going to provide as a LateralTies. So this is step number 6. So first of all, we have to decide what should be the diameter of the transverse reinforcement which we can provide as per the guideline of IS 456. So 456 restrict that diameter of longitudinal by 4. So it comes out to be 7 millimeter, and the second is minimum is 6 millimeter. So following these two guidelines, we have adopted 8 mm dia LateralTies for transverse reinforcement. Even this 8 mm dia already we have assumed, so our assumption is okay, no issue. So now in this point we have to decide what should be the pitch. So first point is pitch should we have to check what is the least little dimension. So column is having 300 by 400, so least dimension is 300, and the 16 diameter of the smallest longitudinal bar. But here we are providing same diameter bars, so it comes out to 448. And the third limitation is that we can say limit is 300 millimeter. So based on all these three parameters, we have decided that we will be providing LateralTies of 8 mm dia bar at 300 millimeter center to center spacing, which is called as pitch and as a transverse reinforcement. Now in last step of the design problem, we have to show the reinforcement details clearly. So all dimensions again we are taking in millimeter. Main steel which we are providing, which we call that longitudinal reinforcement, 6 number of bars of 28 mm dia, and the LateralTies which we have decided 8 mm dia, 300 millimeter center to center spacing. So here we are going to show the reinforcement details, reinforcement detail for rectangular uni-axially loaded column. So you can easily see. First of all, let us see the sectional view. Here 400 by 300 by the outer sides of the column, 62 millimeter by the effective cover, and the red color ring is showing the transverse reinforcement. So that is 8 mm dia, 300 millimeter center to center. and the spacing between these adjacent bars are coming out to be 88, and these black color bars are main reinforcement or longitudinal reinforcement. They are 6 numbers of 28 mm dia bar, and the spacing between transverse reinforcement, that is pitch of the lateral tie, is 300 millimeter. So this is the completion of this design problem, and you are advised to go through similar type of problems by changing different type of data and checking all the parameters, and practice more number of design problem with the help of IS 456 as well as SP-16. Thank you.